My name is Anja Dahlmann. I'm a political scientist and I work at the Stiftung Wissenschaft und Politik. I'm also the head of the International Panel on the Regulation of Autonomous Weapons, which tells you that I work on emerging technologies and disarmament, especially on lethal autonomous weapon systems. To me, it's a fascinating field of work because it combines so many aspects that feed into international peace and security. And we, as a society, have to figure out what role emerging technologies are supposed to play there, and especially what role the human is supposed to play in all of that. AI will kill us all. Well, it probably won't, especially not in the form of a time-traveling robot with an Austrian accent. But AI will help killing people. If AI techniques are combined with weapon platforms like drones, we get a so-called autonomous weapon system. In the understanding of the International Committee of the Red Cross, an autonomous weapon system is a weapon that, once activated, can select and engage targets without further human intervention. This definition is quite broad, but it turns us into the right direction. AI and other technologies make it possible to automate several steps in the targeting process, can help to collect big amounts of data and analyze them in almost real time. That can be, for example, in the form of pattern of life analysis to create target lists, or an image recognition to identify targets. All of those functions develop their full potential in a network where not just one platform collects data, but all of them. To give you a few examples, and starting with some kind of predecessors to autonomous weapon systems. We have the relatively simple system of the Phalanx. Phalanx is an anti-materiel defense system on ships. It can basically, once you activate it, detect incoming munition and then shoot it down by itself, which works well as long as you don't enter a harbor. There, things might go wrong. A similar system, Centurion, is also used to protect, for example, military camps on land. And there, the automation mode is much more restricted and the human has to do much more in the targeting process. Another rather early example is the Skynet program. And yes, they really call it Skynet. Skynet is a project by US intelligence agencies to create target lists, and it does that through behavioral signatures that are based on mathematical methods using mobile phone metadata. Those signatures supposedly identified potential terrorists that became target of drone strikes or other sanctions in Pakistan, Yemen, and Somalia in 2010. There we don't have an autonomous weapon system, obviously, but one step of the targeting process has been automated and has been subject to artificial intelligence. To look at more current systems, we, for example, see the Russian tank Uda. It's currently remotely controlled, but the military is working on developing autonomous functions for it and to enable it to connect to other unmanned ground vehicles and other drones, for example. Then there is the Skyborg project, the Skyborg Autonomous Core System. The idea is to have a plug-in you can use for several weapon platforms, be it manned or unmanned, and connect them through this and enable them, for example, to target autonomously. And that can, for example, create drone swarms, as we can see here in the picture. A European project that's currently going on is the Future Combat Air System, FCAS. It's a project by Germany, France, and Spain. And at the core of it is the development of a new fighter jet, which can be manned or unmanned. This fighter jet is supposed to be accompanied by remote carriers, which is basically small drones. And those will probably have autonomous functions to serve as a loyal wingman, as it's called, to the fighter jet. So we have one fighter jet and several drones accompanying that one. They will communicate directly or through an so-called air combat cloud. There, all the data that is collected by the platforms will be uploaded and analyzed and distributed again. So that is the basic idea behind this. It's supposed to be functional in 2040. We'll see how that goes. But I think it shows nicely the direction in which autonomous functions and AI go with regard to new military options. A similar development is the UK project Tempest. Not a platform, but an operational concept is the Joint All-Domain Command and Control by the United States. Here we don't talk about an autonomous weapon system, but really a new concept to enable multi-domain operations. Again, the idea is to collect a lot of data, to analyze it, and to distribute it, and not just by a few drones or amongst the Air Force, but between the Air Force, the Army, the Marine Corps, and everyone else in the military. And that is supposed to give a very good situational understanding, a very detailed understanding of what is going on the battlefield, and to be able to act very fast. And here, artificial intelligence obviously helps to analyze big amounts of data. Autonomous functions of weapon systems, in that case, would more be a means to an end to be able to act very fast. So as we can see, many countries all over the world, and that was just a small sample here, all over the world invest in autonomous weapons, while this concept of automated targeting is not that novel at all. It does become more flexible, though, to support or replace the human in more complex and more dynamic situations. The overall goal is to make faster decisions. Minimizing the communication between the human and the machine supports that, because the communication link has some delay. It can be detected or it can be interrupted. That happens with remotely piloted drones, for example. By cutting that out and by being able to analyze huge amounts of data, militaries hope to get a better situational understanding and act faster. These examples also show us that a simple definition of autonomous weapons is not too helpful. Instead, it is worthwhile to look into the human role in the targeting process. This targeting process consists of quite a few formalized steps that vary a bit amongst militaries. In the small dynamic targeting cycle, those steps are find, fix, track, target, engage, and assess. Engage means attacking the target in a stricter sense, so destroying a building or killing humans. Artificial intelligence can help to compress this targeting cycle due to fast computing capabilities and less communication between the human operator and the machine. So you can run through all those steps much faster than before. Before this small loop occurs, there is a wider targeting process, and that includes numerous previous steps that range from a political level to the more tactical one. And some of those steps can be supported by AI as well. So far, I discussed especially the beneficial aspects of AI in the military and the targeting process, but some concerns on various levels, starting with the human-machine interaction, so combination of technology and psychology, if you like. One issue with AI or with data-driven computational methods is that they are quite opaque and unpredictable to humans. So it's often not clear how and why an algorithm comes to a certain conclusion and maybe a recommendation to act. Which is also why many developers of autonomous weapon systems also work on explainable AI techniques. And that becomes an issue because humans have a tendency for an automation bias, meaning they tend to trust the computer when it tells them something. For example, if the computer gives you 3 options, you won't ask if there is a 4th or 5th option, you will go with one of the 3. Or when the computer recommends option A, you will probably go with option A because you trust the computer, which is fine most of the time. It can become an issue when there's an error, and it also can become an issue when you have to base your legal or moral decisions on those recommendations. So if the human-machine interaction is designed in a problematic way, then the outcomes will be problematic as well. There could be past dependencies, there could be cumulative errors, and that leads us to some legal, ethical, and potentially also security issues here. The reason for that is the lack of human control, as it's often coined in the debate about autonomous weapons. With human control, I mean something like the situational understanding and options for intervention for a human operator, which is enabled by the design of the system and exercised during use. The exact type and level of human control, however, depends on the operational context. We saw that earlier with the comparison between the Phalanx system, which is used on ships, and the Centurion system, which is used in camps on land, where you need way more human control to protect, for example, civilians. And if we don't have sufficient human control, we will have some legal issues, for example, with international humanitarian law. International humanitarian law tells us is that an attack or for an attack, you have to distinguish between civilians and combatants, and that attacks have to be proportional and all that. And for that, you need a certain understanding and control over the situation to make this legal decision. If that's not possible, we might also have some issues with regard to responsibility and accountability of decisions. From an ethical perspective, we might have an issue with regard to moral agency or the lack thereof. If many steps of the targeting cycle, or maybe all of them, are delegated to a machine, are automated, then no human understands what's going on there. And especially the target becomes a data point and just that. And therefore you make a human into an object, and that substantially violates the dignity of that human. We also, with the lack of moral agency, lack a link to the human conscience. And that is morally very problematic. And finally, we might see some security issues. On a broader level, that could be international destabilization due to arms races and new threat perceptions. And within conflicts, that might be a risk of further escalation due to increasing speed of warfare, but also due to unpredictable reactions of adversarial systems. So if you have two weapon systems with autonomous functions based on AI techniques, and if you put them together, you won't really know what's happening because you never trained them together, obviously. So that could become an issue as well. NGOs and states have noticed those concerns as well, which is why they initiated a deliberation process at the UN Convention on Certain Conventional Weapons, the CCW. This process started in 2014 and is still ongoing, and it's not sure if it really will. If it will be successful or if it will fail at some point. Nevertheless, one potential outcome of this is a ban of the development and use of autonomous weapons, or, in my view, even better, a norm that states the obligation to maintain human control in the use of force. At the moment, states have to figure out how to put this norm of human control into international law. Because autonomous weapons are not a category of weapons. For example, the CCW so far regulated incendiary weapons or blinding laser weapons, and those are pretty clearly defined. With autonomous weapons, we don't have that. We actually talk about a targeting process. And while international humanitarian law limits both means and methods of warfare, this is a novel perspective. So states have to, figure that out with the support of NGOs, of academia, and probably also by the industry who have the technological expertise on that. In addition to the CCW, other fora discuss those issues as well. For example, EU and NATO. The European Parliament just published a resolution where it calls for a ban of autonomous weapons. Furthermore, some states create national legislation around autonomous weapons as well. And this creates an evolving normative framework, but it's still missing some elements, as I said, when it comes to human control and how to operationalize that. And that means that this deliberative norm-making process really lags behind the technological developments and leaves military and industry to set the norms at the moment. And I would say there is some urgent need for political decision makers to act on that. To conclude, will AI kill us all? But it will at least help killing people. There are many military applications and advantages of the use of AI, but some of them create novel challenges and serious concerns. A normative framework is underway while technology and use are evolving as well. So stakeholders, especially political decision makers, have to make sure that we will maintain human control in the use of force. And finally, one word of advice: don't combine AI with nuclear weapons and the targeting process there, because that might kill us all.